Good evening and Assalamualaikum everyone. My name is Muhammad Ahmad Ibrahim bin Zain Abidin and my matrix number is 215676. Okay, imagine a time machine that lets you look back billions of years almost to the beginning of the universe. Sounds like something out of science fiction, right? Well, that is what James Webb Space Telescope or JWST is. Today, I will show you how JWST is not just revealing the cosmos but rewriting the rule book. We'll dive into its discoveries, the challenges it faces, and why it is so groundbreaking. Ready to take a trip to cosmos and time? Let's go. First, what exactly is JWST? Think of it as a Hubble Telescope 2.0 but on steroid. Launched in December 2021, JWST operates around 1.5 million kilometers from Earth. Meanwhile, Hubble Space Telescope only operates at 547 kilometers above Earth. JWST primary mirror size is 6.5 meters compared to Hubble Telescope, which is 2.4 meters, which is around 3 times larger. Next, the mirror composition of the JWST is beryllium coated with gold. This ingredient can be used to detect infrared wavelength. Meanwhile, Hubble Space Telescope only uses aluminum coated with a thin layer of magnesium fluoride, which is suitable for visible and ultraviolet wavelength. Next, even though JWST looks big, it only weighs around 6,500 kilograms. Meanwhile, Hubble Space Telescope weighs around 11,110 kilograms. As I mentioned before, the main wavelength range for JWST is infrared, which is 0.6 to 228 micron. On the other hand, Hubble Space Telescope wavelength only range from 0.1 to 2.5 micron, which is the visible and ultraviolet wavelength. So, JWST operates at a frigid temperature of 233 degrees Celsius, equivalent to negative 387 degrees Fahrenheit. On the other hand, Hubble Space Telescope operates at around 20 degrees Celsius, which is room temperature. And lastly, the key observation for JWST is the early galaxies, star formation, and exoplanet atmosphere. While Hubble Space Telescope observes planetary nebulae, star clusters, and galaxy evolution. I've included the comparison of JWST with Hubble image. We can see here the Southern Ring Nebula, Carina Nebula, and galaxy cluster SMACS 0723. We can see that JWST image is more clearer and HD compared to Hubble, which gives a 90s space vibe. So, one of JWST mission is to find the earliest galaxy, the one that formed just a few hundred million years after the Big Bang. And JWST already giving a jaw-dropping result. For instance, JWST has spotted massive galaxy that shouldn't even exist yet. This is backed by a study from Ferreira et al., which revealed a surprising abundance of early galaxies with some as heavy as billions of suns. So, as we can see in this slide, there are two farthest galaxies, confirmed farthest galaxy. The first one is Mysis Galaxy, named after Stephen Finkelstein's daughter. It's one of the earliest galaxies discovered in August 15, 2023. On the other hand, the farthest confirmed galaxy, recorded in Guinness World Records JWST Z13O, discovered by JWST in September 2022. So, how does JWST pull off these incredible discoveries? It's all about infrared light. Imagine the universe as a crime scene, and JWST played a role of detective. Infrared light helped JWST to see the clues behind dust and gas. Besides that, infrared light allowed JWST to detect cooler objects that does not emit light. For example, brown dwarf, which is fade star, exoplanet, comet, and asteroid. But even super detective faces challenges. In this case, the challenges is called redshift. Redshift is a phenomenon where light stretches and making distant objects appear redder. This can confuse scientists and researchers, as dust can also make things look red. So, they need to double check the image that JWST provide them to make sure that whether it is a galaxy or just dust. So, JWST isn't just a telescope, it's the time traveler and space archaeologists rolled into one. By observing and studying the first galaxies and stars, exploring the birth of planetary systems, and investigating exoplanets and searching signs of life, JWST helped us to realign the cosmic story from the first Big Bang until the big galaxy we see now. Next, let's take a moment to appreciate how insanely cool the engineering of JWST. This is human. Next, the Hubble mirror, 2.4 meter, and lastly, the JWST mirror, which is 6.5 meter. This Webb mirror is bigger than a giraffe. What's more mind-blowing that this mirror folds up like origami and fit into a rocket, and then they launch the rocket and it folds up back perfectly. But here's the twist. Steinhardt et al. Warned that something called cosmic variance made JWST finding tricky. Galaxies in the early universe are spread out as they tend to clump together. So even with JWST, predicting these ancient early galaxies are like finding needle in a haystack that keeps shifting. But what is cosmic variance? Cosmic variance is a statistical uncertainty in observation of the universe due to the fact that we can only see a limited portion of it. So, Steinhardt et al. Note that cosmic variance can create a gap within JWST finding. He also suggests that JWST need to conduct surveys in multiple widely separated regions of the sky to get more statistically representative sample, which means that we can see the space a lot larger, with a larger perspective. So what's next for JWST? It's just getting started as it just launched in December 2021. Over the next decade, it will keep searching for the universe's first galaxies, exploring planets that outside of our solar system, which is suitable for us to habitat. And now, after hearing the marvel of JWST and its mission, what do you want JWST to discover next? A. The first galaxy. B. Habitable planet. Or C. Alien life.
C.
Alien life. Nice choice. Right. So, in the end, the James Webb Space Telescope is more than just a machine. It's a portal to the past. It's challenging old theories, sparking new ones, and proving that this universe is more mysterious than we ever imagined. Science is not a journey, but a destination. JWST is showing that the more we learn, the more questions we have. And that's what makes it interesting. That's all from me. Thank you for joining me into the universe with JWST. Yes,
I do have a question actually.
Yes.
What happens if JWST break down?
Oh, if JWST breaks down, it just breaks down because it's operated at 1.5 million kilometers from Earth, right? Meanwhile, the Hubble is only 547 kilometers. Hubble, we can repair Hubble if it's broken down. So when JWST broken down, it just broken down.
So no one
can repair it. Yeah. No one dare to go 1.5 million kilometers away from Earth.
Like in terms of time, like how, if I'm not mistaken, like when light hits something, there's a time that it travels, right?
Mm-hmm.
So how long is when you get a picture from JWST, how long ago was the picture actually?
Oh, so JWST can observe galaxy from about 200 to 300 million years after the Big Bang, which is, if we compare the time with this, it's around 30 billion years back. 30 billion years back.
That's all.
That's all.
That's all. Thank you.
Thank you.